Okay, so I can help you along with the different one, but let's just take out a sheet of paper and let's just go with new stuff. When you have your independent time, you can work on that and I'll help you out. Okay, so what we're going to learn, ladies and gentlemen, in 5.3 is now we're going to learn how to solve our trigonometric equations. So we've learned how to simplify, we learned how to verify, now we're going to learn how to solve. So solving trigonometric identities or trigonometric equations is going to be just like you guys would solve any other equation. So if you're going to look at this, forget about the cosine for a second and just say you had 2x minus 1 equals 0. Right? We're just going to apply inverse operations. Now it's going to be a little bit different, obviously, because we have cosine in there. But in general, to start, I want you guys just to think about this is just using your inverse operations. Okay? Now, rather than solving for x, though, we now have the cosine of x. However, we're going to follow our same properties. Just use inverse operations to isolate your trigonometric function. All right? So you add 1 on both sides by addition property of equality. Then you divide by 2 by division property of equality on both sides. And you get cosine of x equals 1/2. All right? So this is going back to a lot of problems that we worked on in Chapter 4. And in Chapter 4, remember we said, all right, the cosine of an angle is equal to what? Right? A lot of times we actually didn't use x, we used this. We'd say cosine of theta equals to 1/2. And what that means is, if I say what is theta, that means what angle, when I take the cosine of it, is equal to 1/2. So then we started thinking, we said, oh, okay, well that means cosine of an angle, remember, was equal to the x-coordinate on your unit circle, right? When we were talking about on the unit circle, cosine of theta was equal to your x-coordinate on the unit circle. I don't want you to confuse these two x's. This is dealing with the x-coordinate on the unit circle. This is actually our variable in the problem. So what we did for this is we found the x-coordinates that we needed. So if I'm looking at here for 1/2, I need to figure out, to find this value for this angle, I need to figure out what x-coordinate is 1/2. Right? What are all the x-coordinates for 1/2? And in the problem, we're going to put restrictions. We want our answers only be between 0 and 2 pi. Well, between 0 and 2 pi, that's going to be our unit circle. So what I'll do is we're going to go back to creating the unit circle, right? Which I told you guys you have to know the unit circle, and we have to know a lot of our values. So if I say the cosine of x equals 1/2, what values of theta have an x value of 1/2? So we need to look at our angles on the unit circle, and we could say that, well, I know this angle and this angle. This angle has the coordinate point of 1/2, comma, square root of 3 over 2. And this one has the coordinate point of 1/2, comma, negative square root of 3 over 2. Now, the main important thing is understanding what are those two angles, right? Well, therefore, you could say x within the range of 0 and 2 pi, x is going to equal this angle, which is pi over 3. This is by knowing your unit circle. And then this angle over here is going to be 5 pi over 3. Okay? That's it. So you just need to make sure it falls within the range.